Under normal conditions, generated power on board ship is supplied by one or more main alternators and one or more auxiliary or standby alternators, depending on the power needs of a vessel. These alternators may be driven by steam turbines or diesel engines, although at least one of these should be driven by diesel power in any scheme. Should the normal power supply fail for any reason, an emergency diesel alternator is started up automatically or manually to provide power and lighting for all essential services on board ship. When a vessel is in dry dock, mains power may be supplied from shore. Provision for connecting shore power to the ship's system is given either at the main switchboard or at the emergency switchboard via a circuit breaker. In some cases, a separate shore supply connection box is used, where the supply from shore can be connected near the deck area. A permanent connection will take the supply from the connection box to the appropriate switchboard. The shore connection box is normally fitted with a voltmeter and a phase sequence indicator. In addition to this, a minimum level of lighting, fire and general alarms and communication systems must be supplied by a battery supply during an emergency, when the main supply is interrupted for any reason. The heart of a ship's electrical distribution system is the main switchboard. The generated power is connected to it by the alternator circuit breakers, which connect power to the bus bars. Each alternator has a panel on the switchboard, and the alternators can be connected to the bus bars separately or in parallel. A separate synchronizing panel is located between the alternator panels, which has controls for auto-synchronizing or for manual synchronizing. These may be either a synchroscope or synchronizing lamps, or both. In addition, the panel has voltmeters and frequency indicators. Changeover switches determine whether the meters show the incoming data or the output of the unit supplying power to the bus bars. All these instruments are usually duplicated on the main control console for remote operation. The main switchboard will also contain the reverse power relays, protecting each alternator while running in parallel. Also, a preferential trip system is usually provided for tripping non-essential loads, in case the demand for power is greater than the connected alternator or alternators can safely provide. Several panels on the main switchboard will contain group starters. One of the feeder circuits supplies a bank of transformers, which reduces the voltage level to 220 volts, or in some cases 110 volts for lighting and other consumer units. Another circuit provides typically 24-volt DC supply through a transformer rectifier system. This supply provides emergency power for emergency lighting, the not under command signal lights, certain navigation aids, and the communication and alarm systems on board ship, in parallel with the emergency batteries. On a separate feeder circuit, a battery charger keeps the emergency batteries on charge during normal conditions. The emergency switchboard is smaller than the main switchboard, and it is normally supplied from the main board through a buzz-tie circuit breaker. When the mains power fails, the emergency board is supplied separately by its own alternator. A particularly large example is shown here. The emergency alternator's prime mover is designed to start up automatically when its control system senses a large and sustained drop in the voltage or frequency of the main supply. The emergency switchboard will supply the emergency firefighting pumps and all other essential services. Also, it provides an alternative power source for a steering gear motor and navigation aids, as well as about 30% of the ship's lighting. From the switchboards, power is distributed throughout the vessel via section boards and distribution panels or fuse boards to every load or consumer unit which form part of the ship's electrical scheme.